sitting down for this last section of today's conference. Just a quick two quick organizational things. We're not going to switch rooms after this talk because we only have 5 minutes, so that would be too chaotic. So it's going to be a live stream again. Second thing, somebody lost their glasses. It's in room 6. Please see Daniel if you lost your glasses. With that being said, Amadeus is, as I've heard, you have 10,000 developers as one of the world's largest travel backend, in a sense. Mm-hmm. And we're looking for platform heroics. And I've been promised a lot of smoke and mirrors, very animated discussion and slides. So let's have it for Fabrice and José from Amadeus.
Okay, so hello everyone. So José, you invited me this year at this conference to talk about everything as code. So thank you very much for that. I could not refuse to come to Vienna. And let me tell you, I've got plenty of expectations in terms of automation. So let me jump on it. I've been working for Amadeus for some time. At the beginning, things were easy. We just had one data center, and my life was fairly easy. I knew all the machines by their names. Then it became a bit more complex with more data centers, but just more names to learn. Then when I entered the company, actually, we went for virtualization. Things started being a little bit more complex because no more names, but at least a one-one relationship, so that was manageable. And when you arrived in the company, that became even more chaotic because we went for the migration to the private cloud, to Kubernetes and OpenShift in our case. And so we didn't know there was no name anymore for the pods. And it's just Kubernetes that decided where to put our workload. That was a bit too complex for me. But now it's even worse. We've got more than almost 200 clusters. And so the complexity is astounding. So my demand is quite simple. I need automation. I need automation in order to do my work properly and understand how everything works. So that's what I hope we will explain here. We'll try to take plenty of examples of things that we do in Amadeus, and I hope it will simplify my life as an application owner. So let's get started. I think that the first thing to do is to present ourselves.
Definitely. So thank you, everybody. And my name is Jose. I'm a DevOps engineer at Amadeus. Well, that's basically the same as a YAML engineer, right? And who isn't one nowadays? And if you want to connect with me, feel free to schedule a virtual coffee in my website.
Okay, I see what you did here. Indeed, coffee as code. That's well done. That's one ticked. So on my side, my name is Fabrice Pipart. As you may hear, I am French. And in order to describe what I do, I would say that I'm the please automate guy. So I go to the teams, try to find automations that they can use, advise them, etc. So that's for us. What about our company? How would you describe what we do?
So it was a good introduction, but let me ask you a question. Who of you took flights in the last couple of months or even came to this conference by plane? So did, right? Okay, a couple of you. So thank you for paying our salaries. Anyhow, jokes aside. So we're actually, for those of you that never heard of us, we're actually all over the place when it comes to travel. So people don't usually know us, but if you go to a travel agency, it's going to be Amadeus behind the scene. You go to the airline website, again, Amadeus behind the scene. You go to the airport to do check-in, it's going to be an Amadeus terminal. To do the boarding, flights balance, Amadeus again, and so on and so forth. So we are actually into airlines, rail, hospitality, and everything travel. And I gotta say that we run a fairly big system when it comes to traffic with more than 100,000 transactions per second.
Okay, now let's get started. I want to know how automation can help me and help make my life easier. But I would start with an example of what I expect as an application owner. In my case, I need to manage the permissions on artifact repository, on some artifact repositories. And that is a bit tedious. I wanted to automate that at some time when I heard about GitOps. So what I did is that I did a very simple automation. I just put the payload that should go to the API of Artifactory in a file. And each time we push on a branch, that payload is sent to the Artifactory API. That's absolutely simple, and actually, that works. That was a great way to discover something that looks like GitOps. That is not exactly GitOps, but looks like it. And what we discovered is that the first thing is that pull requests are natural. So it worked very well. It was adopted widely, and we benefited from automatic auditing and approval, all the some of the benefits of GitOps at least. That adoption that was quick was an indication that that automation was something that went in the good direction. And even the things that were not as good were not that bad, because if it was simplistic, it is simplistic. That is true. The fact to have inputs that are in JSON, that's not great, but at the end, people know how to copy-paste a line. That's not that bad. And also, the fact that it overwrites anything that you would do manually on the Artifactory instance is actually a good thing. That means that Git is the source of truth. So at the end, it's said like this, we still use it, and I'm happy with it. Do you have any other automation that is as good as that one?
Sure. So let me introduce you documentation as code, which actually the first as code concept that I started getting familiar with about a decade ago. Because we developers love writing code, but do we actually write docs?
Yeah.
Not that much, right? So I actually got somehow in love with writing documentation thanks to a framework that I discovered some time ago, which is mkdocs. In case you haven't heard of it, you can actually define your documentation in a markup file, in a markup format. Can be markdown in this example, or could be RST or AxiDoc. And thanks to this framework, but there are many others, you can go and preview and render them locally. And off you go. You have your very nice documentation-based space with a lot of other benefits on top of that. It's a great way to actually educate as well users and provide user guides and frequently asked questions. Furthermore, let's take it a notch and let's add a couple of diagrams. So let's explore diagrams as code. So thanks to the syntax of Mermaid, which is yet another framework that you can use, you can actually have sequence diagrams, UML diagrams, and everything that you need to make your documentation space as user-friendly as possible. Whenever you're ready, you can actually push it to Git and let your automation tool of choice do the heavy lifting and build and deploy them in a snapshot. And whenever you're ready, you can go and deploy it in your static hosting service of choice. And the good thing is that it will actually live together with the code. So if you fall back to your code, your documentation will be also in line. So pretty cool, right?
Yeah, thank you, Jose, because anything that can help me write documentation, I take it. Let me jump to another example that I'm sure everyone in the audience implemented some time ago. It's pipeline as code. So we all wanted to have at some point a continuous integration. Let me tell you our journey in that direction. That was 2016, if you remember, if you were already in the business at the time. I was, and what we did is that we developed something based on Jenkins Groovy libraries. We implemented so-called workflows. Remember, at that time, we did not have any GitHub Actions or anything in Jenkins in order to do so, but we just based everything on those Groovy libraries. And we developed so much that at the end, we had something that looks like this. Just a function where you specify what is the technology that you want to use, a few input parameters, and that's it, you've got a complete CI. That was quite successful. The main thing that showed that it was a good idea is that it helped our continuous integration principle spread all over the company very quickly. So it means that that was a good direction. And what was not so good is that we pushed the concept very far. And if there's any one of you that used heavily Groovy in Jenkins, that's not ideal. And also, the operating Jenkins is sometimes a bit painful. And what is also not so great is that we ended up using Jenkins for way too many use cases. It's something that proved to not be great because we could have used something else in some cases. But what was great is that we got CIs that were very complete because it was reusable and we had all the steps necessary implemented. And it enabled us to actually go even further and have security as code. All we had to do is code the necessary step in our CIs, in our workflows, and that's it. Everybody benefited from it. It means that we had scans of our binaries, and we had pull request comments in order to know what was good or not good in our recent changes. All that has been developed thanks to inner source. So that's something that happened at the same time as this continuous integration migration. We developed it internally with communities, and there was no particular owner of the workflows that we created. We all did it together. Remember, we're a big company, so that was a sort of challenge that was new at the time. What I regret a little bit is that we didn't go the extra mile by going open source. That was maybe too early, and if we had to redo it today, that would probably be something to do. So that's it for the CI. What about CD, Jose?
Yeah, let's move a bit to the right and let's get serious. So let's talk infrastructure as code, right? So we need to deploy a lot of platforms, right? So we want to develop an approach so that platform engineers would be able to provide a set of parameters, typically in a YAML format, human readable format, to a rendering engine, which will go and render a set of Terraform modules, which will be orchestrated by Terra Grant. So Terra Grant will be doing the heavy lifting to create the network connectivity needs and routes, and also deploying a full-fledged Azure subscription with all the necessary infrastructure pieces. Together with that one, thanks to the OpenShift installer from OpenShift before, we go and deploy a OpenShift cluster on top of Kubernetes with all the necessary operation framework. We can register that in our ArgoCD clusters in a central control plane, and that way we can actually get all the resources necessary to manage that very Kubernetes cluster and all the necessary pieces to actually serve that eventually. So whenever we want to deploy a new landing zone in a new region, for example, same thing. You provide to the framework another set of parameters, and you get the automation to do all the heavy lifting for you, register that, and there you go. You have another cluster in another region. A couple of things that I like about this approach was the fact that we had an end-to-end blueprinting of our whole infrastructure, which let us leverage the elasticity of the cloud, and also makes kind of easy or manageable the fact of accrediting it. As well, we want to follow a modular approach with inner source templates and modules that enable people to actually create other kind of flavors. A couple of warnings, if you go this approach, be careful of monolithic implementations. So be able to create some implementations that have tight coupling. So that means that one module might actually step toes on another one component failing and making the whole build fail. And the last step, we're talking GitOps. Be careful of avoiding Git-to-Git interfaces. That's a very good advice that I wished I would have learned some time ago. But you have open GitOps to learn about that one anyway.
Okay, thank you, Jose. So now I know how you do to provide me with all those platforms. Let me tell you now what I need. Just before deploying my application, I need it to have connectivity. So let's suppose that I've got that network topology, and I want to expose one of my pods to that end user here on the internet. As an application owner, what I want to do is to have something that is declarative. So I want to just say, I want that user on the internet to reach that pod inside my cluster. That's all I want to do. And I want to do that using YAML, because I'm used to work like this now. The great advantage is that it's declarative. I expect all the platform to use that same approach, declarative approach, so they will all declare where they are in the topology. And that enables us to build an automation that will automatically make the connectivity to my pod. It's something that we developed internally for now. It's not open source yet. There is still the will to make it open source at some point. But that automation, it will build the whole route to my pod. So it will interact with the firewalls, opening with the right rules, Azure network security groups. It will interact with my ingress controller in order to route to. And what I will have with that is finally a zero trust system. It means that everything will be closed by default, and that's extremely powerful. It means that we'll only open what is necessary in terms of security. That makes our white hats and our clients very happy. doesn't go with some problems because since everything is generated via an automation, at some point we had, for example, way too many network policies in our namespaces, so we had to revise that a little bit and to avoid reaching some limitations from Kubernetes. And you got it. It means that it's very powerful. If I want to declare that I want to connect to another pod that is in the same cluster, that's fine. The automation will know the topology and will open the right route. If I've got a pod that is actually on another cluster, I don't need to know about it, but the automation will and will open accordingly everything that is needed. And what is even more powerful is that we can establish some interesting rules. If I never want to connect security zone B to security zone A, when I create the pull request to ask for it, to ask for that connection, actually I will be refused. So my pull request will never build, and I will never be able to merge it, and I will never be able to open something that I don't want, I'm not authorized to open. So very interesting approach that we went for here. Before deploying my application, I need middleware, Jose.
Definitely. So we have the infrastructure and we have the platforms. It's time to start using it, right? So let's talk platform engineering as code. So I couldn't be surprised if you, Fabrice, are managing a number of applications, right?
It's the case.
So the thing is that each of these applications is actually composed of a number of environments: development, staging, production, right?
Yep.
Things get a bit more complex because you are probably wanting to deploy close to your customer and use reliability. So you have different regions, so you need to deploy in different regions as well, right?
Yep.
Well, you know where it's going. Things are getting more complex because you have to configure a lot of dependencies for your application. You need to have your login indexes, you need your Prometheus alerts, database schemas, message hub, you name it. And what is worse, each of them has to be configured differently, right? Well, you get that. Everything I'm talking here is nothing but a complexity problem, right? And how do we manage complexity? We can match it as code, right? So we actually went to decouple a bit of the where, kind of the topology, the logical representation of your application in a human readable file. That is a YAML file indeed. So you can actually convey what your application looks like, right? So environments and descriptions. You can as well codify the what, kind of the grocery list, what you need for your application. So basically, configuration files. Lastly, you need the how, right? So how you actually got to deploy that. So we can create interfaces. We want to create interface into a CLI tool so that we abstract all this complexity for the user. So imagine that you need to configure their Splunk indexes, and what is behind is a centrally ArgoCD consumed repository, which is actually managing config maps. Easy peasy, you use the CLI. You need to configure your Prometheus alerts or Kafka topics by operators, same thing. Database schemas or FinOps metrics, FinOps as code, which actually live off cluster in API resources, same thing. CLI may be able to interact with that. Or quotas, thanks to the infrastructure as code framework that I mentioned to you before. So everything extracted from the user. A couple of takeaways from that was the fact of enabling do not repeat yourself principles for the user with the concept of overlays. So you would be able to overlay just targets at each of the levels. Another interesting approach was shifting left, so being able to gatekeep all the changes before it's too late. Another important remark, I mentioned it before, as code is not necessarily GitOps, so something to improve is the fact that we are actually missing a bit of the reconciliation engine and the pool model, but we're working on that. And the last part, which I think it's a common challenge, particularly for the whole CNCF, is we need to take serious multi-tenancy. So making sure that users' assets are not stepping to each other. So providing some sort of isolation zone.
Okay, great. I've got my middleware. I think I've got everything I need to deploy my application now. So for that will be quite simple. I will just have one advice: use ArgoCD.
Of course, we love ArgoCD, and above all, we love the logo, right? But tell us something more about it.
Okay, I think anyway, most of you probably use something that is similar, either Argo, Flux, whatever. So I will focus on the step before the code review, because we also went as code for that part. So for that, I will introduce the hydration concept. So it's also called the rendered manifest pattern. You've got the authors on the left. And I will describe briefly how ArgoCD works in order to explain that concept. As an ArgoCD user, what you do is that you push your changes to a particular branch. Argo looks at that branch, and that branch is a dry branch because you use a lot of templating. It's a tendency, everybody does that at the end. You use a lot of templating there, and Argo renders those templates in order to generate some manifest. And then those manifests are in the memory of Argo, and it applies it to your Kubernetes cluster. And it does that all the time. That's how ArgoCD works. The concept of hydration is just changing a little bit that concept. You still push to your main branch, so that doesn't change. You still have a dry branch. You still have your templates. Nothing changes for the developer. But what we can do is that we, instead of just applying the manifest right away on Kubernetes, we store them on a so-called hydrated branch. And that little thing changes everything. Because it means that ArgoCD will look at the hydrated branch to apply it, so you still have what you wanted to have. One small difference is that you stop burning CPU all the time to render the manifest, because everything is rendered already. And what it changes is that the diff of that hydrated branch is absolutely readable, because you just have the manifest that will be applied. So if you look at the diff, you know exactly what will change. That changes everything for the code review, because finally you don't have to guess what the templating will do. And also, it's great for your automation. If you want to say, I want necessarily to have that particular label in order to apply it on Kubernetes, you will be able to code that in your automation. So less mistakes. Not finally, but we're also quite happy to follow what the open source community is doing there. So Michael, I will come back to you. I know we met during KubeCon this year. I want to do more in that direction, because we love that approach of hydration. We love it so much that we would like to apply it everywhere. We would like to apply it to Ansible loads, Jenkins, Terraform, whatever kind of loads. We like the fact that the templates are rendered in order to do the code review. And I think that's it for code reviews. There's something else quite important for my production, right?
Right. We're talking observability, right? So let's explore monitoring as code. So last year, I was actually explaining to you how JSONet can help you go and build and deploy thousands of dashboards, thanks to the CLI that we want to develop, thousands of dashboards in Grafana and Prometheus alerts, and that's the reason that we managed to create all these many dashboards for hundreds of airlines to monitor our services or even carbon footprint. But I can tell you a bit of news of another project that we have been contributing quite a lot within Amadeus, and a bit of news. So the thing is that we have a new kit in the CNCF sandbox. Perses, yay! All right. So for you that don't know that much about Perses, it's actually a visualization tool for the whole observability stack of the CNCF. So it comes with a couple of SDKs, Golang and Qlang. Sorry, no JSONet here. So you can actually go and define as code how your dashboard will look like in a standard format. Thanks to the local CLI, we're talking about CLIs, you will be able to preview the dashboard locally, even deploy it in your local instance. Whenever you're ready, you can go and push it to Git, right? And let your automation tool of choice go validate, build it, and deploy it as a snapshot. So you can actually check it before merging it. Whenever you're ready to merge it, you can go and get it deployed in your Perses instance. And what is better? It is embeddable. So you don't need a full-fledged Perses instance to embed it within your UI, as it's come with a number of NPM modules that you can already use. So Perses already allows for visualization of metrics with Prometheus, and traces with Tempo so far. And very soon it will come with logs. That's a bit of the roadmap for 2025. And lastly, it aims to be cloud native. So it has already embedded data discovery from Kubernetes. And very soon it will come as well with the possibility to deploy your dashboards via custom resources.
So it means that I will be able to deploy my dashboard with ArgoCD. So I'm happy, indeed. So Maybe one last one for me that I want to talk about is the change management. It's always been something that is tedious to do and that we wanted to improve and automate. So let me explain how we did that. First, coming back to the basics, I'm an application owner. What I want is to do a pull request and have a load done in production. That's all I want to have. That being said, my operators, they want a little bit more. They've got a few more requirements that they want me to fulfill. So let's detail a little bit that. So that's how I will describe now how we did that in the past, and we'll see how we simplified it recently. So in the past, as a developer, I said I open a pull request, but I also need to open a record. In our case, nobody's perfect. It's a ServiceNow ticket. And in that ticket, I need to put all the information I can. So the impact, what customer is impacted, what systems we'll be using, etc. What type of load we are doing. Is it a test? Is it a production load? And that's it for the developer. Now, one of my peers needs to review what I just did. That's perfectly normal to make sure that someone else checks what I do. Then comes the CAB, the Change Advisory Board, that checks if it's the right thing to load. So they check if I respected the load windows. Maybe the customer that I want to load actually said that it doesn't want to be loaded at that time of the day. They will check the freeze. Maybe that customer said during the next 3 days, please don't load anything for us because we have a particular event. And if they are satisfied, they give me the approval to load in production. And then starts the work of the operator. That person will check if everything is going well, eventually updating some status, and eventually rolling back everything if things went really bad. But that was the past. What we wanted to do is to simplify, streamline as much as we could. So we only kept the human interactions where it was absolutely necessary. So yes, the developers still need to open the pull request, the peer still needs to review, and the CAB still eventually needs to give an approval. We can eventually think about removing that step if you're comfortable with it. But we automated all the rest. So I mentioned it, thanks to hydration, we now have a very precise idea of the impact. So we can, an automation can find that, put the information in ServiceNow, and put the information as metadata on your SCM on Git. In the same manner, since we know the impact, we can have the information for the load window, for the freeze, and again, put that in the ticket and in your SCM as decoration. For the build status, we just need to listen to Argo events, and we will know how well is the load going. And for the fallback, we can use Argo rollout in order to decide automatically to do the fallback or the rollback. And thanks to the Argo events, again, we can put the information in the ticket or in GitHub. So that's it for the change management. It greatly simplified our life. Maybe one last, Jose, for the end?
Yeah, why not? Because everything can be code, right? Should be code. Why not the slides as well? So we can actually edit even these various slides by modifying a markdown file that we all love, right? So we can go here and say something like, I don't know, new stuff. Let's add something here, right? By the way, everything is HTML, so you can render TTY consoles even as well with web TTY. I recommend checking it out, which is great for demos. And there you go. The slides have been edited live, and you can actually see that right there. One last remark that I wanted to mention is that in Amadeus we have our own sort of CNCF with the concept of communities of practice. So 5 years ago and 100 of communities later, we have tons of great as code efforts being put in place. And hey, that's actually the reasons why we actually met different divisions, different projects, and that's the reason we're here.
And yeah, maybe one last thing. We try to give you plenty of examples, try to get some inspiration from it. Some might be useful, some not. But the key message is that try to use communities in order to know what to implement, what to automate in your particular use case. And that being said, thank you. You can download the slide and give us feedback. Feedback is always important. Thank you.
Thank you.
Thank you. Thank you.
Thank you so much. Maybe we have time for a tiny question. Otherwise, I just think it's so important to see how, all these theoretical concepts, quite a lot of very low-level stuff, actually work in real life, because in the end of the day, it's humans that we serve with value, and we do still have like change review boards, right? And so 14 different items as code. Congratulations for implementing this. Applause for Fabrice and Jose from Amadeus.
Thank you.
Thank you very much.
Awesome.